Hey yo everyone, welcome back to Islander Robotics, where I teach all of you robotics through machine learning and artificial intelligence. Today we're actually going to be building upon that data preprocessing class that we were building a couple videos ago. If you haven't checked out that video, there should be a link popping up on the screen. Check it out, click that video, you'll get to see all the mistakes I made at the end. In today's video, I'm going to be explaining what I did wrong and how to fix it. If you like my videos and you want to become part of the Islander community, then consider hitting that subscription button as well as that bell icon so you can get notified when I post my next videos and so that you can become part of the Islander community. Alright, so sit back, relax with your favorite snack, and let's get started, shall we? Very first thing up is I'm actually going to bring up that code. It should be going into the bottom of the screen right in 3, 2, 1. Alright, this is the code that we were working on in I believe right about now. It's a couple videos ago. I was trying to do correlations, but the problem I was running into, and I didn't realize it, I was making that video pretty late, but the problem that I was getting was that this housing.csv has words right here. Ocean proximity, near bay, near bay, near bay, all sorts of different words right here. Machine learning models, algorithms really do not like words. They like numbers. So what we're going to be doing, because in today's video we're actually going to be cleaning up this data so we can do those correlations, is a process in the data preprocessing or well, it's a process of data preprocessing. But you can't skip the data cleaning, which is what I did in the video where I was originally making this video. Making this class. So I'm going to correct that mistake today and make a whole section of the code that does the data cleaning for us. So right about now is when I stop talking and I go into high speed mode. I'll see you all at the other end. So I'm back, and this is I actually made two functions for this class. What one Hot Encoder does is actually, like I was saying, it will take, if I can get the file, it'll take all these words and turn it into numbers. So let me explain this code line by line. So right here on line 41, all I'm doing for line 41, I'm gonna just run it, and I'll tell all of you. Alright, so I want all of you to see that there is a way to actually properly tell what data types each column is. And the one that we want to spend the most attention to is not the float 64, it's the object. Object meaning it's not a number, it's not an integer, it's not a float, it is something beyond that. Alright, so that is the problem that causes errors within machine learning models, is when you have a column that has the object type. Now, the way that we're going to be able to tell that is we're going to actually run a for loop through this whole data set. So it's going to start at 0 and go through the whole length of columns. So it's not going to be going, it's going to be going column by column, checking the type by each column. So after we go to the next line, so on line 43, it's therefore going to check self.data, because if you remember, data is the variable that we created that stores all of the that stores everything from that housing.csv file. And we're going to use the .data types from the pandas library to be able to tell when that data types is equal to O. Alright, so when we're saying O, we're saying the same thing as objects. Now for the user to be able to tell the program what they want to do, just in case they don't want to be able to change these data into another type of format, it's just going to say, hey, there's a column with an object type. Would you like to use one Hot Encoder? Y for yes, N for no. And this is just an if statement. If what dot is lower is equal to y, then start this then start this statement, where it's going to take the changing data. The changing data is going to equal that column. All right. So whatever column is equal to an object type, this variable on 47 is going to equal that type. Underneath, I'm going to specify hot1 is equal to 1 hot encoder. So the 1 hot encoder function is actually coming from the scikit-learn preprocessing, scikit-learn.preprocessing library, and we're going to actually be pulling from the 1 hot encoder right here. So that this on line 7, this is being called all the way down here on line 48, because this is how we're going to change those those words into numbers. And it's a very interesting way on how we're going to do that. After that, we're just going to set a variable equal to the fit transform method of the 1 hot encoder, where we're going to be passing in this data right here. Okay, so this data then gets put over here, and it gets pushed into the 1 hot encoder's fit transform method. All right, and we're going to set that data equal to hot1 data. All right, now after that, we're going to use the .to array from the pandas library to turn this into not from the pandas, from the scikit-learn library to turn this into an array. All right, now what I want to be doing here is what's going to be happening from line 50 all the way for the rest of it is I want to take those values. I want to take the old data, the whole column of that data set. I want to take the old column that had all the words. I want to pull it out, and I want to replace that column with the columns that are equal to the data where they're all numbers. So how 1 hot encoder is going to work, actually I'm going to explain that later on when I run the code, so that you can actually see it, because I can explain it to all you want, but it's not going to make sense unless I actually show you. But we're starting the conversion from this hot1.fit transform is not a pandas data frame. It is a different type of data type. So what we're going to do is turn that into an array, which then can be turned into a NumPy array, which then can be turned into a pandas data frame data type. All right. So that is what's happening on 52. Is we're going from 50 to 52. We're doing the conversion of array to pandas data set. Pandas data frame. After that, we're going to set. So here's another thing: is all those words are going to get turned into column names. So what we're going to do here is we're actually going to set this equal. Bob is equal to a NumPy array of hot1 categories. All right. So that is the name. Those are all the words that were put in. They're going to sort it out and only pick one of each to make it into a column name. If it doesn't make sense yet, don't worry. I'll explain it again once I run it. Right here, we're just saying, so that old column that was equal to an object, we're going to pull it out. That's what self.data.drop. All right, we're going to pull it out, and we're going to set columns equal to self columns at I. All right, and then this is really important, because if you don't do this, it doesn't stay permanent. In place equals true, meaning I want this column to actually be dropped from the pandas data frame. And then I just do a for loop to actually take all those pandas those scikit-learn 1 hot encoder. I do a for loop to actually to combine the old data frame with the new data frame. All right, and I'm just appending the column's name right here, so that I can have an accurate index of what columns I have. And right here, actually at the end, what I want for this class is I actually want a final I want a final CSV file with all of the clean data. With all the data changes that I made inside this class, I want a final version. So that's what I did right here with final CSV. I didn't put it in here because this is one of the steps to clean up your data. So there's going to be a lot more steps, so it doesn't make sense to have the final CSV. Doesn't make sense to have the final CSV command to be put in until the very end, and it makes more sense to be able to use it as its own function within this class. And it's actually very easy to take a pandas data frame and turn it into a CSV file. All you have to do is right here is this is my pandas data frame self.data. I just have to use the .toCSV method and then pass in the CSV I want. All right. Now the last thing I have to do is come over to here and just say self. Where are you? Final CSV. Alright, so with all that explained, now what I'm going to do is just hit run real quick. And oh yeah, before I forget, if you remember in the last video, I kind of kept getting stumped up because of how I had those two inputs that equal one URL. If you don't remember, don't worry about it. But if you do, I got rid of it, and now I just have one URL I have to enter. Should have done that in the last video, but oh well. And then data, we're going to just let it run. We're going to hit Y, and then come over to here, and we're going to just do data, and right here. So each one of those words inside of that data set beforehand, all of those words was either greater than an hour away from the ocean, inland, island, near bay, or near ocean. So what one hot encoder actually does is it turns all of these to 0 and 1. 1 meaning this word was actually put there, 0 meaning no, that word wasn't. So 1, 1, 1, 1, 1 for all these near bay. Now, let me see if I can get a 0 on one of these. I can get a 0. And then 1 right here. Alright, so let's see where that one was equal to. So inland, alright, so this is all zeros right now because before in housing CSV, those were all near bay. Alright, so since those are all near bay, all of these are going to be 0 unless you're in the column that says near bay, which is going to be 1, 1, 1, 1, 1, 1, 1. Alright, so the next thing I actually want to do with this class is before we do the data correlation, I also want to clean up the data because I really don't want Command F. I don't want null being put in. Alright, nope, nope. Come on. F, no. Nope, not what I want. I don't want this. It will cause errors with a machine learning model or as well as AI models. Like I said, today's video is really about cleaning up this data set so that it is usable by a machine learning model. And one thing we have to do is change all of these nulls into a actual number, just like kind of like the same idea for why we turned all these into numbers. So I'm going to be going into high speed. I'm going to be going into high speed and getting all that done. I'll see all of you at the other end. Bye. So I'm back and this is what I came up with. On line 60 is the function that I created. It's just called data cleaning, and all we're really doing is we're going to be using scikit-learn's simple imputer. Simple imputer does, remember a couple of seconds ago for you, like 20 minutes for me, remember how we had a whole boatload of nulls inside of our data set? What simple imputer does is it looks at that whole column, and for each one of those nulls, it puts in the median value. That's why I said for strategy is equal to median. You can really have the strategy be equal to a lot of different other methods, but for what I decided to use was the median. Like I said, it can be equal to a lot of different things. You can really Google that to find out, but what I really think is the best option to use is the median value for that column. So that's what I did on line 61, and then underneath I used an index. I didn't really end up using it. I thought I was going to have to, but I still have it just there because what we're going to need when we're populating this pandas data set is we're actually going to need that index for the width. Alright, yeah, for the width of the new data set, because essentially what it's going to do is create a whole. By using the simple imputer method, when we pass in the self.data data set that we created from the pandas library, that is no longer going to be existent after this goes through. So we have to recreate that inside of this function, which is what we're essentially doing in 63 and 62. We're just fitting the imputer to the self.data, and then we're actually in line 63, we're actually fitting the simple imputer to the data set. I'm using imputer because I set imputer equal to the simple imputer. Now underneath, I'm setting data equal to the imputer.transform. So now I'm actually transforming the data within self data into the data that I want. And then what I'm actually doing is creating another variable called data underscore. Now you can do self.data, but I find this a more cleaner way to just have data be right here, and this is going to be equal to pandas data frame, which is going to just be data column. We're going to say data right here, and we're going to say columns equals self.data.columns, and we're also going to say index equals self.data.index. All right, because so you can either use this method right here. I left this on actually just to show you two different methods. On 62, you can pass index into index, or you can do what I did. I just decided to use this because of it's a little bit of an easier way for me to think about it, because data is already created, which is one of the reasons why I didn't pick this to go right here, because I wanted to use the index from it. Now, if I use this index, put it right there, and just set self data right here, that would have been perfectly fine. But like I said, I find this to be a little bit more of a cleaner way, where on 66 I'm setting the function equal. I'm setting self.data equal to the data that I created right here, which has the new pandas data set. All right, so let's just run this code real quick and see what happens. All right, so now I'm gonna come over to here. Now, since I use the pandas data pandas2 CSV command, there's going to be a null here no matter what. This null is not going anywhere. Hate to say it, but it is not going there, because also the pandas dataset created this whole column right here. All right. Now I believe there is a way to get rid of this, but I really don't mind it. I actually kind of like that each row is numbered. Kind of allows me to think easier on it. And then if I go up to Command F, hit null, the only null that I'm going to get is for this null. All right, so that is all I have for you, for all of you today. This one was a little bit of a shorter one. Really what I want to do was explain how to essentially clean up your data for your machine learning model. This class is not yet complete. I am not finished with this class, but I am going to be working on that in a later video. Because for those of you that remember that were watching my first episode of this whole data preprocessing class, you remember I got stuck up on the correlation aspects. I still want to do that. That is going to be a later video, because that is a whole nother behemoth in itself. But as long as you understand the cleaning aspect, you'll be all set for the data preprocessing. If you want to understand more in depth machine learning beyond what I am capable of explaining to all of you, I really do suggest going to pick up this book. A lot of the code that you saw in today's video did come from this book, hands-on machine learning with scikit-learn, TensorFlow, and Keras. Keras and TensorFlow. It's an O'Reilly book. It is from Jerome. This book, I love this book. It is a huge resource for me, and I'm not done yet reading about this, but it really does explain how to understand. It really does explain machine learning in the simplest forms, all right? Because before you can get to artificial intelligence, you have to understand machine learning, and this book is great for that. Link to this book will be down in the description, down in the description bar down below, as well as the code for this class. All this code will be down in the description bar down below as well. Just remember, this code is not complete. You can use it for your application so that your data preprocessing is a little bit more easier to understand. Like I said, I have this code to be popping out a final CSV just like this. So I'm gonna stop rambling. For those of you that made it this far in the video, you all are awesome. Thank you so much for subscribing. And if you're not yet subscribed, what are you really waiting for? Please go down, hit that subscription button as well as that bell icon so you can become part of the Islander community. If you really want to help support this channel and you really found value out of this video, consider hitting that like button. And if you want to go that extra mile, and then please consider hitting that share button so that all your buddies know how great machine learning really is, as well as that really does help support this channel. All right, so I'm gonna stop now. I'm actually gonna stop talking, and I'll see all of you in next video. Bye, and happy coding.